So in 5.7 practice, we are going to learn about pretty much backwards of what we were doing with distributing. So we're going to kind of learn what's called backwards distribution, or what's called factoring. So before we get there, though, I want you to kind of warm yourself up by just going through these 4 questions and distributing your answer, distributing those and seeing what you get to make sure that you're good and you're fluent with your distributing. So take a minute, pause the video, and go through the warm-up and distribute each of those. Okay, so kind of check your answers here. 6x squared plus 8x is the first one. The second one is negative 15x minus 5x squared. The third one is 10x to the third, y to the third, plus 15x squared, y to the third. And then number 4 is 14x to the sixth, y to the third, minus 7x to the fifth, y to the fourth. Okay, so now we're going to kind of go backwards. So this is what's called greatest common factor factoring. So GCF factoring for short. You've probably heard of greatest common factor before, but it's a factoring strategy, which is really just means like backwards distribution. So what factoring really means is it's like splitting an expression into a multiplication of a simpler expression. So we're going to kind of take a product and split it into two expressions multiplied together. So that's what this is. And so this is one of, I think, 4 strategies we're going to learn how to factor with. So this is the first one. It's the one we're always going to check for first. So it's super important to make sure we have this one down. So the first thing you want to look for, so for example, in number 1, this one is kind of a simple one. So I want to look for a common factor that both of those terms have. So you'll notice that this term has an x, but this term doesn't. So x is not a common thing that those terms have. So we can't use a variable. But if you between 5 and 10 are both have factors of 5, which means 5 goes into 5 and 5 goes into 10. So they're both factors. So I can actually take out their common factor. So I'm going to take out a 5. When I do that, I'm really looking for what's left. So if I take a 5 out of 10x, I'm left with 2x, because 5 times 2x is 10x. And if I take a 5 out of 5, I'm left with 1, because 5 divided by 5 is 1. And so now I have 2 expressions. I have 5 times the expression 2x plus 1 being multiplied together, and it's equal to this product. So you can always check your answers with these. So to check would be to distribute that back. So 5 times 2 is 10x, 5 times 1 is 5. If you get back what you started with, you did it correctly. Okay, so for number 2 is a little bit trickier because now we have variables that are alike. So first, check your numbers. Is there a common factor between 20 and 5? Yes, that the common factor is 5. So I can take a 5 out of both of those things. And then I kind of look at my variables. These variables both have an x. There's 2 of them here being multiplied together, and there's 1 here. So I can actually take out 1x. When I do that, I can only take out 1 though, because this only has 1. They both don't have 2. So when I do that, I kind of have to think about what's left. If I take a 5 and an x out of here, I'm left with 4x. I still have 1 there. And then if I take a 5 and an x out, I'm left with 1, because 5x times 1 is 5x. So again, if I wanted to check this, I would just do 5x times 4x, which would be 20x squared, and 5x times 1, which would be 5x. So I got back what I started with. I know that I'm correct. So then we can kind of just get more complicated by adding more variables, but it doesn't change the process. So again, I'm going to ask myself, what are common factors of 18 and 28? If you can't think of it off the top of your head, try finding some numbers. So I know 18 and 28 both have a factor of 2. I'm trying to think if there's a larger factor. So I think, 4 and 7 can go into 28. 14 and 2. 3 can't go into 28. 6 can't go into 28. So I think that 2 is the largest factor there. And I can always kind of check that later. So If I take a 2 out of both 18 and 28, I can do that. And I can also, this expression has 14 x's here and 3 x's here. So the most I could take out is 3. And then this has 3 y's here and 7 y's here. So the most I can take out is 3. When I do that, and then I got to take them out of each expression. So I can take 2 out of 18, that will be 9. I can take 3 x's out of x to the 14, that'll be 11. I'll take 3 x's out of y, or 3 y's out of y to the third, that will just be 1, so I'll just have x there. If I take 2 out of 28, I will get 14. If I take 3 x's out of x to the third, I'll get nothing, or 1. And if I take 3 y's out of x to, or y to the 7th, I'll get 4 y's left. And so that's the most I can take out. You could check yourself by making sure you can't take any more numbers out of 9 and 14. I can't find any other common factors for 9 and 14, so that's my answer. I could check myself. 2x, 2 times 9 is 18. X to the third times x to the 11th is x to the 14th. Y to the third times 1 is just y to the third. And then 28, x to the third, y to the 7th. So yep, that will work. My answer is correct. Same idea, now we just have a trinomial, so I'm going to kind of go through the same process. Is there a number that 5, 3, and 2 both all go into? 3 goes into 15, but 2 doesn't. 2 doesn't go into any of those. So I don't think there's any numbers that we can take out. However, all of these terms have x's in them. So the most I can, this one has 9, this one has 11, this one has 14. So the most I can take out is 9. So I actually can't take out any numbers in this expression, but I can take out 9 x's. And so when I do that, I'm left with 15 here. If I have 9 x's here, then I'd have to have 5 x's to make it 14. If I take an x to the 9th out of there, I'm left with x squared, 3x squared. If I take an x to the 9th out of there, I'm just left with 2. And so again, I could check my answer by distributing the x to the 9 back in. And I get x to the 14th. And I get back what I started with, which means I did it correctly. So really, it's just like finding out what all your terms have in common, taking it out, and then writing what else you have left. And so that is GCF factoring. So these are your factors, the two expressions being multiplied together. So those are all your answers there. So the practice is really just practicing those skills. So if you look at the back, you're just determining the greatest common factor for all of these. And then there's just a multiple choice. And once you pick your answer, just prove that you're correct just by checking it, just like we did here on the right side. If you have any questions, let me know.